Hi guys, today we're going to think about how a hard-boiled egg is like the Earth and how we can use a hard-boiled egg to model how the surface of the Earth behaves and creates different landforms and events. So first, let's think about how this hard-boiled egg is like the Earth. If we were to open it up and look inside, we would see something like this. We would see this outer layer. It's rigid, it's cracked, and it's very thin. Then we would see this larger white layer and then this round yellow center. What does this remind you of? Why is this like the Earth? Well, I see that we have this thin, rigid outer layer, and that is just like the Earth's crust. Beneath the crust, we have this large white section. It is a soft, solid, kind of bendable, and inside the very center, we have our solid inner core. Now, let's remember what's happening inside this mantle. Inside the mantle, since the core is so hot and the crust is much cooler, we have convection currents. So as material cools down from the crust and it gets denser, it sinks down. When it gets near the surface of the core, which is super hot, it warms up, expands, and rises back up. So all around the core, inside this mantle, we have convection taking place in the asthenosphere. This convection in the mantle actually causes the plates, the crust of the Earth, to slide around and move as the convection currents cycle. So let's just take a look at a cracked hard-boiled egg. Normally this might be an accident. We hate when our boiled eggs crack. But what this actually helps us to see is very similar to the Earth's surface. Rather than being a smooth outer layer like this egg, our Earth's surface, the lithosphere, is all cracked up into all sorts of pieces. Those pieces are called tectonic plates. Earlier this week with our Oreo cookie, we took a look at individual areas and how these plates can move and grind past each other and interact. I want us to realize how that is taking place on Earth's surface and how each plate interaction is influencing plate interactions elsewhere on the globe. So first, let's just take a look at some times when Earth's plates actually head toward each other. What is it called when Earth's plates head toward each other? What kind of boundary is that? Yeah, this is a convergent boundary because the plates are converging on one another, going toward each other. When this happens, if it's happening on dry land, so we have two pieces of continental crust heading right toward each other, sometimes they will start rising up and creating this ridge or this mountain range. This is exactly what happened in the Himalayas when India was converging with the rest of Eurasia, and we have the Himalayan mountain range because of converging plates. All right, now another time we could have converging plates, but if we had converging plates and they have different densities, perhaps like an ocean plate and a continental plate, what could actually happen is as those plates move toward each other, one rises on top of the other. If one is rising on top of the other, what we have here is called subduction. So if this is under the ocean, the oceanic crust piece is going to subduct underneath the continental crust piece. And when we have subduction, that crust is now being swallowed away into the mantle where it's being recycled. This can also happen if we have two pieces of oceanic crust. Whichever one is more dense is going to subduct underneath the other. All right. Additionally, sometimes plates interact by sliding side by side. What kind of a plate interaction is it when the plates slide? They're not going toward each other, they're not going away from each other, they're going exactly in the opposite direction and sliding. Yeah, this is a transform plate boundary. Listen to this sound. kind of scratchy, it's kind of shaky. When these plates grind against each other, this can actually cause an event. What event would that grinding cause? Yeah, that would cause an earthquake. So when these plates grind against each other, they can cause an earthquake on the surface of the earth. That's a transform boundary. All right, our last type of boundary. What do we call it when plates move away from each other? Yeah, when tectonic plates move away from each other, we call this a divergent boundary. These plates are diverging. They're going in their own direction. And when this happens, if it is on the surface of the seafloor underwater, remember, this is exactly what causes seafloor spreading. When these plates diverge, bubbly magma from the mantle can bubble up, instantly harden, and create new crust, new seafloor. That's seafloor spreading. But we also can have diverging plates on dry land, in the continental crust. And when that happens, we end up with a rift valley. You can kind of see this from the side. There is now a deep valley happening here between these two pieces of crust. All right, thanks for following along as I use boiled eggs to demonstrate plate tectonics. I hope this helped.